So let's do some more live integration then, using Maz's megamix of 700 integrals. I quite enjoyed yesterday not having to actually plan anything or write anything properly or think anything through. I just sort of winged it, and I enjoyed that. So let's do some more. I also enjoyed reading people's solutions um, that I didn't get or didn't think of, different ways of doing things that I thought were interesting. Anyway, 595 is this one here. So if you do find a solution to this that I don't find, please pop it in the comments. I'll be interested to read. So I can't remember already what this was. I think it was a fraction here, if I'm not mistaken. I think it was 1 minus x over 1 plus x, was it? Yeah, it was. Okay. So 1 plus x in here, and then 1 minus x in there. dx, obviously. Good. So this is the integral that we're looking at. It looks kind of interesting already. Weirdly small integrand there, but that's okay. So what are we doing here? I have no idea to start with. Um, there's a few things I could think to do. Like obviously making a substitution u equals 1 plus x would be a potential idea here because it would make the denominator simple, and simplifying denominators is always a good thing. Du clearly equals dx there. 1 minus x, what does that even equal in terms of u? So you'd move the x over, I guess, and then you'd have to add 1 to both sides and take away the thing. So I think it would be something like u minus x equals 1, obviously. And then to make that a 1 minus x, we would have to take away u from both sides to get this, but then also add in another 1 to both sides. So we end up with something that looks a bit like this. And of course, the transformation is fine, so this would just be a du. So 1 minus x is 2 minus u, and then we just end up with a u on the bottom, which seems like an easier thing to maybe do, although still not really sure how easy this is, to be honest. This still doesn't seem that helpful. Maybe it is helpful, maybe it's not. This root is annoying, and I'm not sure how I'm going to get rid of it. So let's have a think. Um, it's just 2 minus u to the power half isn't very helpful. There's nothing going on here that's log-like, so that's not very helpful. Maybe I'm barking up the wrong tree here. Maybe the solution was to do something a bit different from the start. I'm going to leave that working there just in case I want to come back to it. But what if you took this here, and what if you times the top and the bottom of this fraction by something fancy like this, I guess? Maybe? I'm allowed to do this, right? That's just timesing by 1. So obviously this would make a 1 minus 2x plus x squared in here. The reason I did this was because it makes a 1 minus x squared over down there, but I don't know how helpful this is either. I mean, I'm being an idiot, right? The numerator would actually come out quite nicely there because there was 1 minus x twice, so that just roots away. So rather than being that, this actually looks like this with this square root here. So maybe this is helpful. And I think it might be because if I get rid of this, because I think I no longer want that. I don't think this is right. I think what I've done here is okay. So I'll end up with that, which turns into this. And now the reason I think this is okay is because I can split this into 1 over root 1 minus x squared minus x over the same thing, which I think is good. No, is it not? This is a standard result, so that's fine. This one here looks, what is this one? What is even going on here? So it's x times that to the minus half. Yeah, it's just inverse chain, right? Because it's, if I just say it's something like x into 1 minus x squared to the power minus a half, is what this second term essentially is. If I just raise that up, yeah, it's got everything it needs. So I think this integrates to something that looks a bit like, ooh, this goes away. Half times the 2 cancels, so that's all good. And we just need the negative. No, we don't, because of this minus 2x from the derivative there. So I think that just differentiates, sorry, just integrates to this. And then we have to deal with this guy. I can't remember which integral this is. So I think I decided a while ago that I was allowed to use the A-level formula sheet. So let's do that. So here it is, integrals, integration. So which one is, I'm in the wrong section. There, no, here, there we are. Here it is. So which one am I in? I'm in 1 minus x squared rooted, which is this one. Good, so it's arc sine of x, because a is just 1 in our case. So I think this is just arc sine of x plus that object there, and I think we're done with this integral. I think it's just that. Cool. That was an interesting one. Quite a difficult integral, actually, but also quite fun. So yeah, quite fun though. Anyway, let's go on to maybe another one. So random num generator, 595 becomes 490. So let's search that, 490. There it is. So this looks different for sure. Let's copy this out, delete all this, delete this. Ooh, can't click it, delete that. So I can't even slightly remember what that said. So I put a little fraction in here because it was definitely a fraction. Right, I got a cos plus a sine on the bottom, so I'll put that in. So immediately as I'm typing this, I'm thinking that our formulas could be possible here to make that a little bit better. And then 3 sine x minus cos x. Minus cos x. And then what was the last bit? Plus 3. Okay. So what on earth is going on here then, we ask? So like I said, R formulas seem possible here. You could do an R formula to deal with this guy, and you'd get it in the form, like, let's just write something. You'd get it in the form, you'd have some R, it'd actually be root, it's 3 squared plus, it's root 10, isn't it? But it doesn't really matter, of sine of x of something. Again, I'll just put some number there. And then this one is also an R formula. I think this one actually, from the top of my head, is root 2 into sine of x plus pi over 4, I guess. Something like that. So, okay, that's fine. What I'm doing here is I'm just asking the question, would this help? Because now I could maybe break down the fraction into halves and do this over this. But the problem is this number here, would it match this number here? Is that something that works? That's something that works, because this would be, would this actually work? Is this also pi over 4? Because if this is also pi over 4, this is just what you do. And is this root 10? Like, is that just how that works? I'm a bit worried about the minus, obviously. So that's not actually going to work, is it? Because this will be like a 3 pi over 4. So I don't think this is actually what you do. I mean, I could do it properly, couldn't I? And actually figure it out. So the R formula that I'm following is, I guess, sine of, x plus a is sine of x cos of a minus sine of a cos of x. Is it a plus? It's actually a plus, isn't it? Okay, so that's actually a plus. Because of course it's 2 lots if it's the same thing. So, okay, so we've got, and I guess I need an R's here. So we've got, I'm sure I'm there. So this one might take me a little bit longer because I'm not very good at R formulas because I don't use them very often. Maybe I should use them more. Maybe I should just be better at them. But anyway, we've got that we need the first cos of a to, well, we need R cos of a to equal just 3, I guess. And we need R sine of a to equal what? Like minus 1. So we divide them and we get tan is, no, it's not going to work. Okay, so tan is some garbage. Minus a third doesn't work. Okay, so that's immediately that plan gone, because with the fractions not matching, or with the numbers in those things not matching, I just don't see how this is doable. Yeah, so that's not a good idea. Okay, T formulas came to mind. What if we did something similar to what we did before? I said T formulas out loud, just with almost no intention to actually use them, because I really didn't want to. What if we just times top and bottom this fraction by this? Now, this only springs to mind because on the denominator of that fraction, you're going to get cos squared minus sine squared, which is good because that's 3 is great, because that's cos 2x, which seems hopeful. Now we just have to be really careful to multiply all of this correctly on the top. So it's going to be 3 sine, and then we're going to have minus 3 sine squared x. And then the next term is going to be minus cos squared x. It's a shame that this doesn't really go away. Sine x cos x is going to be here. This is a plus as well, and then plus 3 cos x. And then minus 3 sine x is, I think, the whole thing. Okay, so is this in any way useful is the next thing we need to ask ourselves. So we end up with 4 of these guys, which is actually just 2 lots of sine 2x. So I'll replace that there, get rid of all this. These don't really go together very well, which is annoying. Like I said, this is cos 2x, which is why I did that. But this 3 just messes up like everything, I think, because I can't really use sine squared plus cos squared anywhere because they don't match. Is there some way to factorize that so it makes it look really good? Because can you use like, but even if you could, like, how would that be helpful? I'm thinking like, no, because the cos and cos, and you got 3 of those there, so that doesn't work. Yeah, that's frustrating. So that doesn't seem to work either, I don't think. Cool. I mean, it's not cool, it's really annoying. Okay, so how on earth do we get this to work then? Just like, what do we do? How do we get this to work? Um, the fact that this top one's a minus is annoying. If this is a plus, you could like split it and make this, because the numerator would put like some of it you could make match and you could make fraction 1 and some other stuff. But that doesn't work because of the minus, so that's annoying. I totally don't know what to do here. T formulas are my last. Should I try a T formula? Okay, let's just do it. This will be the last thing I try. So T equals tan x over 2 is what we need to try. This, I'm not going to do the proof, but this leads to sine of x equaling, I can't even remember, is it this? No, yeah, right, it's that, right? And then cos was this one, I think, was the 1 minus t squared. Okay, so that's that. And then I think, off the top of my head, or should I actually just do it? Dt, just check I get it right, is sec squared x over 2. This obviously needs halving as well. So I'll put that there. Dx. Now sec squared is, or sec squared beta over 2, or x over 2, is 1 plus t squared, because it's 1 plus tan squared, so that's a half into 1 plus t squared. And then, yeah, we can divide to find, or we can double and divide to find that 2 over 1 plus. Okay, so that's what I thought it was. That's good. It's there. Okay, so let's put all of that in there, I guess. So we get this here is here, minus this here. It goes here. And then this is going to be the first one. And the other one, that's decent, I guess. And then this gets replaced with all this. I don't think I have a huge amount of hope over this, but I mean, this is nice on the bottom here. So all those 1 plus t squareds cancel, which is quite nice. So, I mean, this 2, I'm just going to put out here. And then what I'm saying is that these 1 plus t squareds, they all cancel on the bottom. So this just ends up being 1 plus 2t minus t squared on the bottom. That's the only thing that's left when you add it to the other bit. That's cool. Now let's think about the top here. It also is 1 minus t, or no, it's not. It doesn't factorize at all. Amazing. Okay, so I've got to hope that something else works here, I guess. So this is what's going to happen here. So this is 6, obviously. And then we're going to take it away. Those go together. I guess this is, if we put this over 1 plus t squared, it's 3 plus 3t squared. Can you even type? Can you just type, bro? Anyway, what does that all come together to make? So it's 4, no it's not, it's 2 uh, plus 6t minus is plus 4t squared, I think, is what that all came together to make. If I've got that wrong, I'll be really annoyed. Obviously, you can factorize out 2 from that. Just to leave this. I'm not sure how this is helpful. Does that factorize on the top there? Does it factorize to make 1 plus 2t, 1 plus t? It probably does. It's also not helpful, is it? Because there's no cancelling that can happen here. Like this times by this. This is just a mess, right? Because we already discussed that this doesn't factorize, which is super annoying. So I think I've just made this problem worse. like, we've literally made no progress at all. So great, super fun. Uh, there's literally nothing I can do with that, I don't think. And fantastic. Unless it just so happens, let's keep this one more thing to think about. Let's put this here, and then let's put this guy underneath here, and let's think about what happens if we expand these two things, because it's possible, very unlikely, but it's possible we could get some kind of log out of this. Nope, it's not going to happen because you get a t to the 4 term then, it derives to t to the 3, which doesn't exist on top, so that doesn't work either. Fantastic. Feel free. I mean, I guess at this point, this is theoretically possible if we now, I'm going to have to get some more stuff out. We could do this with partial fractions from here, right? Because we've got some kind of factorized thing going on. We could say that it's something over this one plus something, or minus, doesn't really matter, over the other one. Now, the problem is thinking of these things is going to be probably quite tricky. I'm going to shove a 2 here just because that gives me a 2 ski squared and then a 1 here. Let's just try, just because that definitely gives me, no, it doesn't because the minus, so plus. So a 3 here, because I'm just trying to make the t squared match. So this gives me 3t squared minus t squared, so that's fine. I get 2 t's there, and I get no t's from over here. So how do I make more t's? Plus t here, casually. But then I'm going to get t cubed, so that doesn't work. So how do I get another t out of this? Do I actually have to do partial fractions properly? It seems like I might do. So okay. Let's do it properly, I guess. A t plus b on the top, and ct plus d. Let's just think through. Would this actually be helpful? It would. This would actually get me the answer eventually, right? Oh, would it though? Okay, well, it might do. It has some hope. Apologies for this being the longest video of all time. But in any case, I imagine most of you already done this, I would guess. So let's put this bad boy here and start comparing. Okay, so this line says that at plus b into 1 plus t squared. Already annoyed that I can't really just do some cheap substituting to get the answers here. I mean, let's face it, there's no way this is actually going to get uploaded to YouTube because it's too embarrassing. So we'll put the bracket, v bracket, 1 plus 2t minus t squared. Okay, all of that needs to equal the top line from the other one. So it needs to equal this. Okay. I mean, how are we even going to go about doing this? So a minus c needs to equal 0 because we need the t squares to match. Sorry, the t cubes to match. And that's the only place we're getting t cubes from. Okay, that's fine. So the constants then b plus d equals 1. I think that says, which obviously isn't helpful yet. There's no substitute I'm going to do to just make this work, is there? There probably is, but I can't be able to figure out what it is. Minus 1, does that make this work? 1 minus 2, no. And 1 also doesn't make it work. Okay. Of course, because I already talked about how this doesn't factorize. So um, yeah, cool. I'm just an idiot. Okay. So next we have t squared. So bt squared uh, plus. Uh, okay, so b plus what's going on over here? Minus, sorry, minus d needs to equal the 2t squared from there. I'm not getting t squared from everywhere else, am I? So that's fine. I can't really. Okay, well, these two are helpful. So add them together, you get b is 3 over 2, which of course means that d is minus a half. Then let's cross-reference against the c's. So the c, sorry, the a's and the c's. So the t's. So a plus c, no, 2c from there equals 3. Okay, so if we double this first one and add them together, we're going to get 3a equals 3, so a equals 1, which means c equals 1. That works, I think. Okay, so we end up with the integral of, and this is the moment of truth, does this even work? T plus 3 over 2, well, that's not a good sign, plus ct plus minus a half. Okay, so this is awful in almost every way. So this one's fine because I can break that halfway. So if we get out another page, I'll just demonstrate why that one's fine at least. I'm just worried about the first one. So this second integral is fine because it's t over the thing minus the half. The half obviously doesn't matter into this, oh sorry, into the same thing, into 1 over 1 plus t squared. And that's, this is just arctan, this integral. So this is minus a half arctan. This is inverse chain rule. We actually saw it before. So those two things are just fine. Now this over here is more problematic, right? Because it doesn't work in the way that I want it to work, or at least it doesn't seem to initial look at. So the problem is that this here isn't the derivative of this down here, so that's problematic because the derivative of this is minus 2t plus 2, which the two factors are wrong, like it doesn't quite work here. I could make it work, like I could force it to work here. So for example, if I wrote this as plus 1 and then plus another random a half later, and then I took this half and put it into its own fraction, like here, just like I have done with the other one. So, does it? Yeah, that's fine. So something like this. If I factorize out the half, it's weird. I'm just going to put the half there anyway, because that was where it was before. So if I do something like this, this one works now because, oh no, it still doesn't even work because this needs to be a minus to make this work, I think, because it needs to be the wrong sign from what this derives to. Okay, so if that's a minus, this needs to be, it was plus a half, okay, it was plus 3 over 2 plus 1.5. So now it needs to be plus 5 over 2. Um, so I think this is now integrable. I think 3 out of 4 of these things work. I think the first one is log. I'm just going to ignore the 4. 1 plus 2t minus t squared. And then I need to factor that with a minus a half, I think, to make that all work. The third term is inverse. It's just 1 plus t. We actually saw this earlier, didn't we? To the power a half. And then the half and the t, it just all cancels. And we end up with this. The last term is, like I said before, it's a half arctan of t, I think. So that's all fine. Why am I using t's? Oh, because I used the substitution earlier, didn't I? It was a t substitution for about 5 minutes. It's more than 5 minutes. It's like 15 minutes ago. Okay, so we do have to put this back at some point, but okay. Um, now this one is difficult, or is it difficult? Is there one last thing I can do with this? Um, so that's okay. So let's times this by 4. So this is 2 here, This is 4 here, and this is plus 2 here. Okay, so that's 3 of the terms. Now this last term is just this integral. Now I can put the 5 over 2 outside, so it's going to be 10, I think, into here. So this is just the last thing that I need to try and do. I think I have a way of doing this. I think I can say that this is the integral of, if I complete the square, I think this will just about work. So so this point that we remember that I can't even complete the square, I'm going to be so, this is so dumb that I'm resorting to this. Let's put the minus out here, just to make it easier for me to complete the square in my tired and frustrated state at this integral. So it's t minus 1. Ooh, t minus 1. Minus 1 minus 1 is minus 2. And that should obviously be an all squared here. Okay, and now I think this is just a standard result. If you imagine t minus 1 is just like u, you get minus 10 into u squared minus 2. And I think from here, we have that result here. No, we don't. Here, u squared minus, yeah, so it's going to be, so a is going to be behaving as root 2, because root 2 squared is 2. So a is root 2, so this is 1 over 2 root 2 log of that thing there. So this is minus 1/10 times 1 over 2 root 2. Ooh, sorry. 2 root 2 into log of, now let's just get out some bars because let's be particular. Now this is x is t minus 1 minus root 2. I think it was minus on top, right? And then plus on bottom. It was, so t minus 1 plus root 2 here. So I think that's that thing integrated as well. The brackets aren't being kind to me. There it is. That's the third term in this absolute mess of an integral. So I think I have these 4 terms is the entire integral. Now, we made a t substitution earlier, and that t substitution was t equals tan of x over 2. So, okay, this is, so this has to go, so this has to go into all of this. So let's delete and delete some more. All I need is like the first, like these 4 things here. So I can just type them all in with some. So it's this, it's this. Is this a minus? Where did that minus come from? Oh, because I swapped that. Okay, I'm kind of happy with that, I think. I mean, by the way, this is in no way right. There's obviously going to be mistakes here. But and then this is the substitution. So x is arctan of 2t, which actually isn't useful because I've replaced this. This is tan of x over 2, and this is tan squared of x over 2. Okay, and this is tan of x over 2, and this is tan of x over 2, and that's all good. I mean, let's just say this is there, and that's a 5, obviously. Just tidies up a little bit. So that's all that done. This, or t squared, is again just tan squared x over 2, so that's the next term. And then the last term is arctan of t, which is kind of interesting. Arctan of t is just x over 2, is it not? It's for our 2. Yeah, no, arctan of t is just x, right? X over 2, which times by 2 to make x. Is that the answer? Let's pretend that this is some form of the answer. Well, that was ridiculous. There's no way that's right. So have a nice time pointing out in the comments why I'm so wrong with that. But in any case, that was quite fun.